The first one that I've got is from Mpilontle. Mpilontle, I hope you're watching. It's a very nice question. The question deals with coordinate geometry, analytical geometry, as some people call it. And it has to do with lines in circles. So there's a circle, there's lines in the circle, there's tangents to the circle that we're going to find, and you guys know that you can expect this question, where there's an angle between two lines that you need to find. So let us see. On the screen, we have a circle given to us. The center of the, let me just undo that one. The center of the circle is given to us as this point over here. So that's quite nice that we have that information, because immediately we can now say that the angle here will be 90 degrees, because the line segment NP is not just any chord of the circle, it is a chord that passes through the center of the circle. So it's called a diameter. And we know that from geometry, angles that are subtended by the diameter is a right angle on the circumference of the circle. So that angle Q is 90. Then they say in the diagram, the circle with diameter NP, good, confirming what we saw here, is given with the coordinate pair n as -2 and 3, and the coordinate pair here at P as 4 and -7. And the first question that they ask us, folks, is to find the equation of that circle. Now remember, your circle, if it is centered at the origin, is x squared plus y squared equals r squared. So the only thing that you need is to find the radius. Okay, because for those circles, the center is located at the origin 0, 0. Well, our circle that we're working with is not. So we know that the circle has a form x minus a squared plus y minus b squared is equal to r squared. So this is the first part of Mpilontle's question. And folks, they're asking us to find the circle in that form, which is quite nice. They don't want us to multiply it out. Okay, so let's see. The detail here is that that is the center of the circle, grade 12s. So the center of the circle has been located here, and it is the midpoint of the chord or the diameter NP. So immediately we know that we have to apply our midpoint formula to find the center. So let's do that. We're going to call that center, I'm going to call it C. Okay, so for the x coordinate of C, what do? I add the two x values. So it's 4 minus 2 over 2. Well, 4 minus 2 for centuries have been 2. Nothing has changed. So 2 over 2 is 1. The y coordinate for C is the same thing. 3 minus 7. All of that divided by 2. Well, that's minus 4 divided by 2 gives us minus 2. So with that information, we have the center of the circle, folks. And remember what I said to you. Get into the habit when you're working with functions in the first paper, or when you're working with either geometry or coordinate geometry in the second paper. The information that you just found, put it on the diagram, because you're going to use it going forward. So the point C, we can say, is the point 1 in the x direction and minus 2 in the y direction. So now we can go back to our formula. X minus this 1 all squared plus y, now this is minus 2, which becomes positive 2. Folks, from the center in coordinate pair form to the equation, the signs are changing. Make a mental note of that. Once you've got the coordinates of the center, to put it back into the equation of the circle, you change the signs when it goes into the circle equation. So that's squared, and that then gives me the radius squared, which I don't have. So now I've got an option. I can work out the distance of CP, or I can work out the distance of NP and half it. Okay, so for R, let's go and work out the radius CP. CP is the square root of. Now, we're not going to need it because we need CP squared. We don't just need CP. Why is that the case? Because in our formula, we have r squared. So let's not bring in our square root. So it will be the x value there minus the x value here. So my 1 minus 4 all squared plus minus 2. Now that's minus 2 plus 7 on this side, all squared. Folks, so that gives you minus 3 squared, which is 9. This gives you 7, positive minus 2 is 5, and 5 squared is 25. So it looks like the radius squared is indeed 34. Let's just check ourselves. Minus 2 over here, plus 5. There we go. 1 minus 3. Don't make silly sign mistakes. Okay, that's going to cost you dearly. If you make a sign mistake here, your answers are not going to be correct. So there we had 5 squared, which is 25, 3 squared, and then I know that my radius squared is indeed 34. So to finally, that final answer would be that x minus 1 all squared plus y plus 2 all squared is indeed 34, as the radius for 34 is the radius squared. Remember that. Okay, so that was a nice, easy part to this question, is finding that equation. Now, in Polintle, I hope this is making sense to you. The second part of your question is asking for the equation of the tangent at the point N. Now, let's go to our graph and have a look. The tangent at the point N is this line over here. And we know from our geometry days that the radius or the diameter of a circle is perpendicular to the tangent at the point of contact, which we do have. So we've got a point on the tangent. We're now either going to look for another point that lies on this tangent, or we're going to look for the gradient. Can we find another point? The answer definitely no. So we need to look at the gradient of this diameter that we just worked with to find the center. So for the tangent, I'm going to call it the equation of TGT, the tangent equation at point N. The gradient of the line NP is the first thing that I'm going to need. Now, folks, I know you can't see that, so let me just move it in. There we go. That's better. So we have to find our gradient of this line. Now that's 3 minus 7 is 3 plus 7, which is 10, the change in y, over the change in x. Minus 2 minus 4 is minus 6. Okay, so the one was positive outcome, the other one has a negative. We can see that 2 goes into both of these two, the denominator and the numerator. So that leaves me with 5 over 3. My gradient for my radius is 5 minus 5 over 3. So what's the gradient for the tangent? Well, we turn the gradient of the radius, we call it reciprocated, and we change its sign. So we can say the gradient of the tangent is 3 over 5. Now we've got enough information. We have the gradient of the tangent, and we have the coordinate of the point where the tangent lies. Okay, so that point is minus 2 and 3. So it's y minus 3 is equal to the gradient of the tangent, x plus 2. Remember, this is x minus 2, another sign change. Now I've got a fraction here. I always trip over fractions because I think they're so easy. So what I always do as a matter of safety is I get rid of them. I multiply both sides with a 5. So I've got 5y minus 3 times 5 is 15. I take the 3 in, I have 3x plus the 6, beg your pardon. And now I've got to clean this up. So this is 5y, which is 3x, the 6, the 15 comes over, leaves us with plus 21, and then just a division of 5, because they asked us to leave it in the form mx plus c. So we need to divide that coefficient of 5 away. If they didn't ask for a form, I can leave it like that. Okay, but in this case, they said mx plus c. So if we divide by 5, we get 3 over 5x plus 21 divided by 5, and there's the tangent to the curve at point N. Now let's quickly just remind you guys again. What did we have? We had the coordinates. We in fact had 3 coordinate pairs on NP. So we could find its gradient. We used the grade 11 theorem for this relationship over here, and then found the gradient. We had the tangency point, so things worked out quite nicely. We just had to interpret that. Okay, let's see. This is now the nice part of the question. Polintle, so I think maybe this and the next part of the question is what was challenging to you. 4.3, folks. They want the size of the angle NPQ. NPQ. And then they tell us the coordinates of Q is 4 and 3 in the y direction. Okay, and they want the size of this angle over here. I'm going to call this angle alpha for now. They want that size over there. Now, folks, look at this question. Always look at the x values of points and the y values of points. In this case, we've got y values that are the same, and we have x values that are the same. Look at this. The x value for Q over here is the same as the x value for P, which means this line is a vertical line. Now that's dangerous because the gradient of a vertical line is infinite. It's something divided by 0. And this is where the trick comes in. If lines have a delta x component of their gradient 0, let me write this down somewhere for you. So if, oopsie, let me go down. We're going to look at question 3. I'm going to leave the color as is. The gradient of any line is delta y over delta x. If delta y is 0, the line is horizontal. Now, folks, if we look carefully, let's go back to the diagram. This line here has 2 y values that are the same. So for that line, delta y is 0, so it's parallel to the x-axis. For this line, this vertical line here, delta x was 0. So if we put this into gradient form, it will be 3 minus 7, so it will be 10 over 0. Delta x is 0, so the line is vertical. If delta y is 0, the line is horizontal, which is the case within Q. If delta x is 0, the line is vertical. Now, why am I gunning on about that, folks? Let me just put the second note here for you. If delta x is 0, the line is indeed vertical. Now, that's very important, because if you try and find the gradient of the line, your calculator is going to say it's an error. It's not really an error, okay? Remember, in the gradient, we don't work with a value 0. We work with the fact that the change in x is 0. The change in x is 0, or the change in y is 0. So the line is vertical. Now, if I draw that line here, there's another line that crosses it. This is the line with a gradient that's infinite. If I go back to my diagram, the point where it crosses is 4 and minus 7, so it's the line NP that crosses over there. This here is point P, which is the point 4 and minus 7. If I need it, I've got it. I don't think I'm going to need it. But let's have a look. Then I have the other end point of that line, which is the point N. Do I have the gradient of NP? I do. I worked with a gradient of NP when I worked with a tangent. Here it is on our screen. That's the gradient I wanted. So this gradient I have it's 3 over 5. Okay, sorry, that's the gradient of the tangent. It's the one at the top that I'm after. It's this one that I'm after over there. So the gradient that I'm wanting is minus 5 over 3. It's a negative gradient. Let me just get my pen back here. Okay, so it's minus 5 over 3. Now, folks, if I put, this is what I always do. I always put a horizontal through the point where I want to start working with angles. I already have one angle there. I've got the right angle. Let's fill it in another color. I've got that right angle over there. The angle I'm after is this angle alpha. Now, there's double trouble in this question. The gradient is negative. So if you use your calculator, it's going to give you a negative angle. Now let's see, where is that negative angle? If we look at the diagram, the answer is going to give, the calculator is going to give you this angle here. That line is, that's a line, this is a line, that is a line. They intersect at this point. So these vertically opposite angles that I'm forming over here are equal to one another. Okay, so don't forget that. So the angle that I'm going to find is this. Well, once I've got this angle, I'm going to add 180 to it, and it will give me this complete angle over here. Once I've got that complete angle, Mpilontle, I hope you're watching this and you're following my argument. Once I've got the whole angle, I just take 90 degrees away and I've got alpha. So I suggest for you matrics, always, always, always draw the diagram. Don't redraw the whole thing, just the point where the angle is. Fill in the gradients if you have them and start filling in angles so you can see what you're doing. It helps to fill those in. Okay, so for that big angle over there, let's just call it beta for now. Beta will be 180 degrees plus the size of this angle. Now, how do I find the size of that angle? Well, I know the following. I know that the gradient of AB, any line, is equivalent to the tan of the angle that the line makes with the positive x-axis. So if I want the angle, I must inverse tan the gradient. So this is going to read the tan, oops, wrong color. The tan inverse of my, let me just select my nice color there, the tan inverse of the negative gradient, which is minus 5 over 3. Now, folks, you've got to make sure that your calculator is set on degrees and that it's not on radians. Once you've done that, once you calculate this, you get 180, and then that angle has a negative value. The negative value of that angle is, if we round it off, minus 59 degrees. If you take your calculator, you calculate that, you get minus 59 degrees. You add 180 to that, so this is this angle here. That's the minus 59. If we add 180 to it, we land up with that angle there, because this is just taken away from 180, and that leaves us 121 degrees. Now we've got beta, this big angle over here. I didn't want beta, I wanted angle alpha. Can you see what I mean, folks, if I say draw the diagram, fill in various angles so that whoever looks at your work at the end of the day can see what you're working with and is on your argument with you. Okay, that's very important. When we mark your matric papers, and after about marking 200, 300, 400 papers, and you don't know what the child is doing, it gets difficult. So you want to make it as easy as possible on whoever reads your work. Make sure that you do, when you work with angles between lines, you replicate that diagram on your script. Okay, so now we can finish off. What is alpha? Alpha is this beta minus 90 degrees. And if you take 90 degrees away from that, your result for this angle is indeed 31 degrees. So the angle over here that they're asking us to find is 31 degrees. Mpilontle, sorry. Mpilontle. Your problem here was the fact that your gradient was infinite. Delta x was 0. That's the first problem. The second problem is the way the lines are slanted. If you put that value in your calculator, you get a negative angle. So always draw this picture. It helps you negotiate what you are looking for. Now, the last part of your question, I enjoyed very, very much. Let us write, I'm going to write it down and then we're going to go back to the diagram. So this is part 4. They're asking us for the ratio of the area of triangle, what is it, PQN, over the area of circle, the area of the circle. I called it C because remember we always name circles by their centers. So I want the area of circle C and I want the area of that triangle. Let's go to the diagram. This is why it's important to fill all the information in on your diagram. We saw that this line was horizontal, okay? We've got a right angle in our triangle. There's a horizontal line, there's a right angle. So I've got a base and possibly a height. Let's see. What's the length of the base? Well, if it's horizontal, immediately I can say that that length there is the bigger number minus, remember the y values stay the same. So I look at the x values. 4 minus minus 2 makes that distance there 6. Because this is vertical, I look at the difference between the two x values. There's 7 at the bottom, 3 at the top. So that length there is 10. And look at how easy this now is. It's half base times height, or half base times height. Okay, so it's half of 60, which is 30 for our circle, or for our triangle. So it's a half base, which is 6, multiplied by the height, which is 10, and that gave us 30. And the circle, now, well, all we need is the radius of the circle. The radius we have, the radius is 34. The area of any circle is pi r squared. Okay, so let's put that in. The area of the circle is pi 34 squared. Now, it's not 34 squared, it is already squared. Be careful, be very careful. I'm making a silly mistake here. This is the radius squared already. Okay, so I've got pi over 34. If I simplify that, 2 goes into the top 15 and 2 goes into the bottom 17. So 15 over 17 pi. That is the relationship between the area of the triangle and the area of the circle.